Modern applications need databases that deliver consistent performance and low latency, no matter how large the workload. Cosmos DB in Fabric provides exactly that. A high-performance NoSQL operational database built right into the Fabric ecosystem. In this demo, we'll use Spark and the Cosmos DB Spark connector to interact directly with a Cosmos DB container, all from inside a Fabric notebook. This walkthrough is based on the Spark Scala notebook you can download directly from the Cosmos DB Fabric samples repository. Once that's downloaded, let's switch over to Fabric. Here I've already got a workspace with a Cosmos DB database deployed and a sample dataset loaded. Let's start by importing the notebook we just downloaded and opening it. Before we dive into the notebook, let's take a quick look at the Cosmos DB database itself. You can see the database sample database and within it the sample data container. These are the documents we'll be working with today. Because Cosmos DB is a NoSQL database, we can store JSON documents for different entity types with different schema, all within the same container. For example, here is a document where the document type is product. It includes product-specific fields, plus a price history array showing its historical prices. If I opened a different document, you'll notice the document type is review and its properties are all review related. The container is partitioned by category name, meaning each document is uniquely identified by its category name and ID combination. Before returning to the notebook, let's copy the Cosmos DB database endpoint. We'll need that in a moment. Back in the notebook, you'll see a section listing the prerequisites. First, we choose the language, then we configure the Spark environment. I'll select my pre-configured environment called Cosmos DB Connector. If we open that environment, you can see I've already added the required Spark Connector custom libraries, so we're ready to go. In the first cell, we define the variables for the endpoint, the database, and the container names. I'll paste in the endpoint we just copied and confirm that the names match my database. Now the notebook's ready to run. Let's connect to Spark. And here I'll run all cells. I'll walk you through each step as we go through the notebook afterwards. Here we define a configuration map with settings for our container. Next, we create a data frame with a Spark read operation. The format is set to cosmos.oltp, meaning it's performing a direct container operation. Schema inference is turned on, so Spark automatically builds the data frame schema from the documents it reads. The first 5 rows appear below, and as you can see, each JSON property has been projected into its own column. Next, we print the data frame schema. It's now strongly typed, combining fields from both document types in the container. We can filter the data frame to just the product documents and show the first 10 rows. Then we can filter it again to only those in the computers laptops category using the filter function. Now we'll configure the Spark catalog to use our database schema, calling it Cosmos Catalog. This allows us to run Spark SQL statements directly against Cosmos DB containers using the Cosmos Catalog.database.container name naming convention. Here we built a simple SQL query and ran it. The results look exactly as expected. Let's do something a bit more analytical now. We'll load another data frame using a SQL statement. This time we explode the price history array, turning each price into its own row. Then we'll aggregate by product to find the lowest price ever recorded for each one. The results show 1 row per product with its lowest price ever. Next, we'll write this data back to a new container in Cosmos DB. First, we create the container with a SQL create statement. We need to specify the partition key, and in this case as ID, and set the throughput, in this case to 1,000 request units per second. Since every document needs an ID, we'll need to set it to the product ID. That way, future lookups are fast point reads. Then, we define the right configuration for the new container. We set the right strategy to item overwrite, which lets us update any documents that already exist. Finally, we call the save function to persist the data frame. To confirm, we'll read back the data. And yes, there it appears exactly as we expected. Let's jump back to the Cosmos DB portal and refresh. Here, the new container we just created, opening it, you'll see each document matches one for one with the rows in our dataset. That's it. We just used Fabric Notebook and Spark to read data from a Cosmos DB and Fabric container, perform some analysis and write the results back, all within the same workspace. This demonstrates how your operational databases and analytical tools can live seamlessly together in Fabric. No longer extra environments to manage, just one unified platform for building truly data-driven applications.